Hello, this is Jacob Shimek,
and Sean Wirt.
and here's our presentation on the Shiga-like toxin and its molecular story. During May, June, and July of 2011 in Germany, an epidemic of gastroenteritis and hemolytic uremic syndrome occurred. The cause of this outbreak is believed to be the result of the consumption of sprouts and the inadvertent ingestion of fecal matter, which is believed to be the vehicle for Shiga toxin-producing Escherichia coli. Ingestion of this Shiga toxin-producing Escherichia coli can result in the development of hemolytic anemia, anemia caused by the destruction of red blood cells, acute kidney failure, and a low platelet count. Figure 1 on the right depicts an instance map of this outbreak.
Shiga-like toxin, specifically variant 2, portrayed here in figure 2, is the main cause of the outbreak in Germany. It is commonly abbreviated to STX2. Now, STX2 is a holotoxin, meaning that the toxin has multiple subunits. The function of the toxin starts with the B unit, also called STX2B. STX2B is a pentamer with 5 basically symmetrical monomers making up its structure. STX2B has multiple binding sites that allow the toxin to bind to glycolipids on the exterior of cell membranes. Then, the A unit, commonly referred to as STX2A, enters the cell and breaks into 2 parts, the A1 and A2 subunits. The A1 subunit then cleaves an adenine base from ribosomes. This may not seem to be a huge deal, but this specific adenine base is required in binding elongation factors to the ribosome. Without these elongation factors, ribosomal protein synthesis is completely halted. We will be investigating the B unit here. As previously stated, the primary function of STX2B is to bind to the glycolipids on the exterior of cells. In most cases, the B unit binds to a glycolipid known as globotriaosylceramide, thankfully abbreviated to GB3. The tryptophan amino acid at residue number 29 in 4 of the 5 monomers is displayed in lime green in figure 3. This is binding site 1. It is not present in the 5th monomer since the A1 subunit feeds through the B unit, and the glutamic acid at residue number 84 in the A1 subunit obstructs this tryptophan residue. The tryptophan amino acid at residue number 33 in each of the monomers is displayed in blue. This is binding site 3. Both binding site locations bond to GB3, or globotriaosylceramide, on the exterior of cell membranes.
While this toxin can be deadly in an outbreak, researchers are attempting to utilize Shiga-like toxin to improve cancer treatment. GB3, whose chemical structure can be seen in figure 4 below, is a glycolipid common in cancerous tumors. GB3 is especially present in testicular and breast cancers, and can be bound to by the B unit of the holotoxin. By specialized, targeted use of Shiga toxin in cancer patients, tumors could potentially be more effectively detected and treated. We created a 3D printed model of our protein, which can be seen in figure 5. The C termini of the backbones are painted red, the N termini are painted blue, binding site 1 at the 4 residues of tryptophan 29 is painted yellow, binding site 3 at each tryptophan 33 residue is painted green, and the structural supports are painted black. Our print came out very cleanly, and our model is an accurate representation of STX2B. Our teacher recently went to a convention in Milwaukee, Wisconsin, where she learned about these protein models and purchased some professionally printed protein models, including a print of an STXB unit. Our printed model looks very similar to the professional one, which demonstrates our success in producing an accurate model.
Here, in figure 6, you can see the stark similarity between our printed model and the structural display in JMOL. We really appreciated this opportunity to learn about protein structures and to 3D print a protein model. We did encounter a few roadblocks in this project. We had multiple painting errors, causing the painting stage of this project to drag on, as we fixed and perfected the model's paint job. Moreover, a segment of our model with an end terminal had snapped off, and we had to hot glue it back on. Regardless, this project went very well. The applications of this project are very interesting. By understanding the B unit's binding properties, we can further investigate the outbreak in Germany and the occasional outbreaks in developing communities, where animal feces contaminate the water supply at much more of a substantial level. In terms of cancer research, the information on implementation of the STX-B unit in detecting cancer is not yet fully understood and may not be entirely practical due to the toxin's effects on patients. Ongoing studies may bring new findings to light. These are our resources, and thank you so much for watching!